Hello, brilliant minds. Welcome back. If EMF scares you, don't worry. Today we are going to break it down in the simplest way possible. And now in this video, we are seeing about Maxwell's fourth equation, which says that electricity and magnetism are not separate forces. When electric field changes with time, they generate magnetic fields. This dynamic coupling between electric field intensity E and magnetic field intensity H is mathematically expressed in terms of Maxwell's fourth equation. It is also called as modified Ampere circuit law, which is modified by James Clerk Maxwell. In this particular equation derivation, the first step we'll see the original Ampere circuit law from studies current case. The line integral of magnetic field intensity around a closed path equal to the total current enclosed. In integral form, we can write it as closed integral of h bar dot dl is equal to I enclosed. Using the current density equation, I enclosed is equal to surface integral of j dot ds, where j is current density. So we can write closed integral of h bar dot dl is equal to, in place of I enclosed, as surface integral of j bar dot ds. Now if we apply Stokes theorem for this, the left hand side of the equation becomes closed line integral of h bar dot dl is equal to surface integral of del cross h ds. And if we substitute this, it becomes surface integral of del cross h ds is equal to surface integral of j bar dot ds. Since surface is arbitrary, we can say del cross h is equal to j bar, and taking divergence on both sides, del cross h is equal to del dot j. But as you know, the divergence of a curl of a vector is equal to 0. Therefore, we can say del dot j is equal to 0, which means that current must always be steady. There should be no charge accumulation. But from continuity equation, we know del dot j is equal to minus dou rho by dou t. So for time varying fields, we can say the divergence of current density is not equal to 0. So original Ampere's law fails for time varying fields. So if there is a small correction in the Maxwell's equation, so Maxwell introduced displacement current density is dou d by dou t, nothing but displacement current density. So total current actually becomes, it is sum of conduction and displacement current densities. So J total is equal to J bar plus dou d by dou t. So we can say the modified Ampere's law in integral form, closed integral of h bar dot dl is equal to surface integral of the total current J plus dou d by dou t into ds. And if we apply Stokes theorem again, LHS becomes del cross h is equal to J plus dou d by dou t. And finally, in differential form, we can say del cross h is equal to J plus dou d by dou t, which mean that conduction current produces magnetic field, and time varying electric field also produces magnetic field, and this equation made electromagnetic wave theory is possible. So we can say without displacement current there is no electromagnetic waves, with displacement current only electromagnetic waves are possible. Thank you.